Hi guys, this is Mrs. Scott. So I thought I would throw in some bad jokes of the day. I don't want you to miss them if you're not in class. So here's your bad joke of the day. Why is your nose in the middle of your face? Because it's the center. Oh, that's a good one. Okay, so let's take a look at some theorems. So we're going to answer this question here today. What are the four different relationships created when parallel lines are cut by a transversal? So we talked about transversals in the last section, and it turns out that when those lines that are cut by a transversal are parallel, there's some properties that the angles have. So let's start out right here by creating a couple of parallel lines. So let's make these red. And we're going to draw two parallel lines here. And then we're going to cut them with a transversal. So if these two lines are parallel, remember we should put some arrows on these to show that. And now what happens is that it turns out that the corresponding angles are congruent when two parallel lines are cut by a transversal. Okay, so for example, if I called this up here angle 1 and angle 5, angle 1 would be congruent to angle 5. Okay, let's look at the next theorem. This one deals with alternate interior angles. So again, let's start with two parallel lines cut by a transversal. And in this case, we know that alternate interior angles are congruent when two parallel lines are cut by a transversal. So let's look at an example of that. Angle 3 and angle 6. If these two lines are parallel, so we should probably put some arrows on there to show that, it turns out that angle 3 is congruent to angle 6. So these have the same angle measure. Just like above, angle 1, that obtuse angle, has the same number of degrees as angle 5. All right, let's move right along here. So next we are going to look at the alternate exterior angles theorem. So again, you guessed it, we're going to draw two parallel lines, and let's make our transversal go this way this time. This theorem tells us, again, that now alternate exterior angles are congruent when two parallel lines are cut by a transversal. Okay, so it turns out that if you have alternate exterior angles, let's say angle 1, and we'll call this one way down here angle 8, these two angles are congruent. So angle 1 is congruent to angle 8, but remember that is only true if these lines are parallel, so we better make sure we put some arrows on them to show that they are parallel. All right, so just remember, corresponding alternate interior and alternate exterior angles are always congruent if the lines are parallel. Now the reason that I didn't mention the next theorem yet is because that one is a little bit different. So we're still going to start with two lines cut by a transversal. And now we're going to be looking at the consecutive interior angles. So for example, angle 4 and angle 6. So we can see that these two are definitely not congruent because if you look here, 4 is obtuse and angle 6 is acute. So they're not congruent, but they are supplementary. So consecutive interior angles are supplementary. So this is the only one that follows the rule that they're supplementary when two parallel lines are cut by a transversal. All right, so it doesn't mean that 4 and 6 are equal, but it means that the measure of angle 4 plus the measure of angle 6 has to be 180 degrees. So for example, if angle 4 was 100 degrees, we know that angle 6 would have to be 80 degrees because they have to add up to 180. So it means to be supplementary. So consecutive interior angles are the only ones that don't quite follow the same relationship that the other three do. All right, so let's just look at two examples using this information. All right, so the first example that we will look at, we have two parallel lines. Notice these triangles here, that means they are parallel, and they're cut by a transversal. So if we know that these lines are parallel, we're going to find the value of the variables. In the case of example 1, we're going to figure out what x equals. So if we look at these, we got to determine what type of angles we have here. Well, these are consecutive. They're on the same side. They're inside the parallel line, so they're interior angles. So if we have consecutive interior angles in this picture, that means that we're going to have to use that very last theorem that we talked about, that they add up to 180 degrees. So 75 plus 5x minus 10 is going to equal 180. These two are supplementary. All right, looks like we got some like terms to combine, so let's combine this 75 minus 10, giving us 65 plus 5x equals 180. We can go ahead and subtract the 65 from both sides. These will cancel. Then we end up with 5x equals 115. So dividing by 5 will give us x is 23. Okay, let's look at one more example here. Now this one's going to involve a couple of steps. So first of all, they tell us that line L and line M are parallel. That's what this says right here. And let's look at the x variable first. So this and this, if you remember, those are corresponding angles. They're in matching positions. So if we have corresponding angles, remember that we can set this angle equal to this angle. Because if those lines are parallel, corresponding angles are congruent. That means 4x minus 50 is equal to 2x plus 30. So let's use some algebra here to solve for x. I'm going to start by subtracting the 2x from both sides. Then we end up with 2x minus 50 equals 30. Go ahead and add the 50 to the other side. And we end up with 2x equals 80. So if we divide by 2, x is 40. So we found x. We do still have to go back and figure out what y is. So with this one, I don't really have a whole lot of information to find angle y. So what I notice is that if I plug in x right here, 2 times 40 plus 30, well, that's 80 plus 30. That means this angle right here is 110 degrees. Well, if that's 110 degrees, that means y is going to have to be 70 degrees because these two angles right here make a linear pair. So 70 degrees plus 110 degrees, that means y is going to have to be 70. Okay, so that's the only two examples I have for you guys today. Make sure that if you have questions with this stuff, you ask, because we're going to use transversals and parallel lines quite a bit throughout this whole chapter. So thank you guys for watching. Make sure you ask questions if you got them. See you later.